Some of the most dangerous forces on Earth don't roar. They wait. Not for days, not for years, but for centuries. Off the coast of the Pacific Northwest lies a fault so quiet, most people don't even know it exists. A 1,000-kilometer subduction zone, capable of producing magnitude 9 earthquakes. And it hasn't made a sound in over 300 years. In geology, that kind of silence is never a good sign. If you love science-based deep dives into the forces shaping our planet, hit subscribe. Now, let's uncover the truth about Earth's next megaquake. Cascadia is unlike most faults we hear about. The San Andreas cracks and shudders consistently. Japan's Nankai Trough releases magnitude 7s and 8s on a regular cycle. But Cascadia is completely locked. There are almost no small warning quakes, no grinding, no rumbling. When a fault stays silent, it isn't harmless. It means the two plates are stuck together, building strain deeper and deeper year after year. And when that strain finally overcomes the friction holding them in place, the entire edge of a continent will move. To understand why Cascadia is capable of such massive earthquakes, you have to look at the mechanics of the fault itself. The Juan de Fuca Plate, a remnant of the ancient Farallon Plate, is being pushed beneath the North American Plate at a rate of about 4 centimeters per year. That doesn't sound like much, but tectonic plates aren't smooth. They're rough slabs of rock with locked patches where friction holds them together. As the oceanic plate is forced downwards, it drags the edge of the continent with it, bending the crust like a giant spring. The deeper part of the fault creeps steadily, but the shallow coastal portion stays locked, storing energy for centuries. When enough strain builds, the locked zone gives way, releasing centuries of motion in a matter of minutes. That sudden unbending is what produces a magnitude 9 earthquake. For centuries, Indigenous oral histories across the Pacific Northwest described a night where the land shook and the ocean swallowed the shore. For a long time, Western scientists didn't understand what that meant. Then the evidence appeared. Along the coast, researchers found ghost forests. Cedar trees all killed at once when the ground suddenly sank during a massive earthquake. Beneath tidal marshes, layers of sand reveal repeated tsunamis sweeping inland. And in Japan, historical records describe an orphan tsunami, a wave that struck on January 26, 1700 with no local earthquake. The source? A magnitude 9 Cascadia rupture, the last time the entire fault broke. Cascadia also behaves differently because of the type of friction along the fault. Instead of slipping in frequent small earthquakes, the plate interface here is dominated by what geophysicists call stick-slip friction. The plates don't glide smoothly. They stick hard and then fail catastrophically. This is why the region produces almost no moderate earthquakes. The fault is too tightly locked to release the strain gradually. GPS instruments show the land being compressed horizontally and lifted vertically as the edge of North America warps under the stress. This bending stores elastic strain in the crust, energy that rocks can only hold for so long. When the accumulated stress exceeds the strength of the locked interface, the crust rebounds to its original shape. That rebound is the earthquake. It's the same physical mechanism seen in multiple megathrust events, and Cascadia follows the same geologic rules. Today, scientists can measure plate movement with extraordinary precision, and the story that they're seeing is unmistakable. GPS stations across the Pacific Northwest show the entire coastline being slowly pulled towards the oceanic plate, bent like a loaded spring. The seafloor pressure sensors offshore confirm the interface is locked tightly. No slip, no release. That stored energy doesn't just disappear. It only has one way out. And Cascadia has produced magnitude 9 earthquakes every 300 to 600 years for thousands of years. We are currently 323 years into that cycle. When Cascadia finally ruptures, the break will start deep beneath the ocean floor and tear through the fault at nearly 2 miles per second. The shaking will last 3 to 5 minutes, longer than most earthquakes on Earth. Long enough for buildings to fail from accumulated stress, not from the first jolt. When the locked plates snap, the coast could drop by up to 2 meters. Rivers will reverse, estuaries will flood, and some shorelines will move permanently inland. And then comes the tsunami. Because Cascadia runs parallel to the coast, the first wave isn't an hour away. In many places, it will arrive in 10 to 15 minutes. Not enough time to drive. Barely enough time to run to higher ground. The shaking and tsunami are only the start. Liquefaction will turn entire neighborhoods built on soft ground into unstable, shifting sand. Landslides could bury valleys across Washington, and critical infrastructure, water lines, power grids, bridges, and ports will all face stresses they weren't built for in the 20th century. Recovery won't be a matter of days. It will be years, possibly even decades. Here's the part that really makes headlines. A Cascadia Megaquake is survivable if preparation is taken seriously. Communities are mapping vertical evacuation routes. Schools are training students to head for high ground, and scientists are deploying sensors to give precious seconds of early warning. The future megathrust earthquake is inevitable, but a disaster doesn't have to be. If you want more science-focused, no-hype videos about the powerful forces shaping Earth, subscribe and explore the rest of the Dangerous Earth series. There is a lot more to uncover.